3 newly discovered worlds risk doom orbiting too close to dying stars. Astronomers have put their might to the test and have carried out the discovery of 3 new worlds that are orbiting exceptionally closely to their parent stars, and these worlds might well be on the edge of extinction. Make sure you subscribe to our channel and press the bell icon to get notified of our newest videos. To be precise, these are exoplanets in our solar system. They have been seen at a huge risk of being extinct because they are present in such extreme places. Not more than 10 years ago, nobody had an idea about them. Everyone thought they didn't exist, but that isn't the case right now. This was the explanation given by Samuel Grunblatt, the lead author of the study of these planets and a postdoctoral fellow at the American Museum of Natural History. He spoke on these planets after a news conference by the American Astronomical Society on January 13th. The exoplanets. The 3 exoplanets TOI 2337b, TOI 4329b, and TOI 2669b have been identified as gas giants having masses between 0.5 and 1.7 times of Jupiter. With more mass, these planets are also much bigger, and they've been suggested to have varying origins. The observatories that have studied them have explained that since they are exoplanets, they are nowhere near in terms of properties to any planets on our solar system. These planets are mainly composed of gases. Knowing about them is essential because planetary systems tend to show the evolution over time. These new observations offer new windows into planets that are reaching the end of their lives before they end up being ingested by the host star. When a star evolves and enters into the last 10% of its life, it reels in nearby planets and, in turn, manages to alter the orbit of the planets around its parent star. This happens as it could destabilize an entire planetary system or cause planets to collide with each other as they come into contact. More heat is produced when planets come together, which triggers atmospheric changes on a massive scale, such as swelling. These kind of interactions explain the varying densities between these newly discovered exoplanets. Detailing in on these exoplanets, it is seen that all 3 of them have some of the shortest orbits discovered, and that too around giant dying stars. The orbital period of TOI 2337b, for instance, suggests that this exoplanet is going to be consumed by its host star in less than 1 million years, which is way quicker than any other planet known. With the services of Transiting Exoplanet Survey Satellite or TESS on hand, hundreds of such planetary systems shall be discovered with new details on how they should interact with each other, inflate, and migrate around stars such as our Sun. Studying systems like these will provide us with a better understanding of what we should expect from these planetary systems, along with understanding our solar systems and the potential that it holds. TESS observations are needed to know the rate at which these exoplanets are spiraling into their stars. One of the most significant contributions to these is the James Webb Space Telescope, which will help identify the composition of the planets and their atmospheres, and in turn how these planets are formed. Not just that, with such closely knit orbits around their parent stars, these planets will need the right kind of instruments to be tracked carefully, and the James Webb Telescope is going to contribute to just that. Rapid changes of the star combined with short orbital periods of these planets imply that these planets are consumed by their host stars quicker than any other known planets. As we continue the study of such systems, they can tell us how these giant planets move throughout the remainder of their lives. It also allows us to focus on how the nature of these stars affects their smaller neighbors, and puffs them up through these fiery deaths as they die their host stars. Now that we've discussed their exoplanets overall in detail, we shall now be looking into the details of each of these exoplanets. TOI 2337b. This planet has its planetary status confirmed as of now, and the official year in which it has been discovered is 2022. Of course, with no sign of it any time before, the orbital period of this planet is 2.99 days, with its eccentricity at 0.019. The angular velocity of this planet is 300 degrees. Along with a radius that is 0.9 times that of Jupiter. A primary transit did the detection method, and its mass detection is carried out by radial velocity. Thirdly, the radius of this planet was detected by the primary transit method. TOI 2337b's impact parameter b is 0.52 with a velocity semi-amplitude of 192.2 ms. There are still several details that need to be known of this planet, such as its half-life, calculated temperature, measured temperature, hottest point longitude, geometric albedo, and surface gravity. Right now, only its discovery is made. Hopefully all these minor details will be discovered soon as this exoplanet nears extinction with every passing day. TOI 4329b. The second planet out of the two is TOI 4329b, which also has its status confirmed as a planet having a mass of 0.45 times that of the mass of Jupiter. The orbital period of this exoplanet is 2.9233 days and has an eccentricity of 0.068, that is minus 0.068 plus 0.079 specifically. At the same time, the angular velocity of this planet is about 16 degrees. This planet has a radius of 1.5 times more than the radius of Jupiter. These details were obtained on this exoplanet in January 15, 2022, and the main detection method of this exoplanet was done by primary transit. And the mass of this planet was detected by radial velocity. Additionally, the primary transit method was used to detect the radius of this planet. The value of the primary transit comes in at 2458165.068, that's plus or minus 0.002 JD. Finally, this planet has an impact parameter B of 0.24 and a velocity semi-amplitude K of 55.6 ms. The star of this planet, which is TOI 4329, has an age of 2.39 gigayears and an effective temperature of 6000 Kelvin. Both 4329b and 2337b had their radiuses known by the primary transit methods. TOI 2669b. This exoplanet orbits a giant red star roughly every 6 days, and it isn't Mars because Mars is present in our solar system, whereas this planet is outside our solar system. Apart from the two above mentioned, this also had its status confirmed as a planet this year, only a few days ago. Its mass is the biggest out of these three exoplanets, being 0.61 times that of the mass of Jupiter. The orbital period of this planet is 6.20 days, and it has an eccentricity of 0.09 and an angular velocity of 140 degrees. The radius of this planet is 1.76 times that of Jupiter. A primary transit did the detection method, and its mass detection is carried out by radial velocity. Also, the radius of this planet was detected by the primary transit method. The primary transit has a JD value of 2458521.598, plus or minus 0.009, and an impact parameter of 0.86. The velocity semi-amplitude K was 59.6 ms, with many specifics on this planet yet to be discovered. These include its temperatures, geometric albedo, and surface gravity log. There are no alternate names designated to this planet either. The three planets explained above have been discussed in a publication titled Test Giants Transiting Giants 2, the Hottest Jupiters Orbiting Evolved Stars, which was carried out by Grunblatt S., Saunders N., Sun M., Chantos A., Soares Furtado M., et al., and published in the Astronomy Journal. With only the discovery of these exoplanets so exciting, we can only hope to see what the future of these planets has in store for us. If we find habitable conditions on them, we can only put them into theory, since leaving our solar system is impossible with the current technology and spacecraft that we possess. These are some of the finest exoplanets that have been discovered in recent times, and although exoplanets are bound to be extinct, these worlds are at the cusp of it. Their stars will end up devouring them, and so much about them is still yet to be known. Even with so much technological advancement, we are limited by the technology of our time, which has only allowed us to locate these exoplanets and bring us general information about them. It would have been quite incredible had we gotten the chance to visit these planets, but there are some things that even nature doesn't allow. Although man is never curious to go to these places even when nature doesn't allow it. We can also hope that we shall get to see more exoplanets in the coming times, since the James Webb Telescope finally opened at the start of this year. Everything related to astronomy is going to be a treat this year.